my friends, welcome again. So this video we will talk about the BTS7960 module. Okay, this one is a BTS, which is a half bridge driver. Okay, we can use it to drive any load with maximum of 43 amp. Okay, this is really useful and very powerful. So in this video we will try to run a DC motor. I guess it's a 12-volt DC motor. Okay, and since we have two half bridges here, each one of them is, as we will see later in the data sheet, each one of them is considered as a PN half bridge with two MOSFETs. So both of them considered as a H bridge, so we can drive the motor and control the speed. At the same time, you can control the direction, whether clockwise or counterclockwise, because we have complete H bridge. Okay, so we will use this module with the Arduino. Okay, we will connect the module to the Arduino, and also the load, as I said, will be our 12-volt DC motor. Okay, so now let's go to the computer and we will have a very fast review of the data sheet of this module.
Well, guys, so this is the model we're going to use in today's tutorial. Okay, so if you can see here is a pre-soldered complete solution as a motor driver. It consists of two pieces. Let me make this one thicker and red. We change to this guy. Okay, of two pieces. This is the main ICs of the module, okay, which they are the BTC, okay, the H bridge. So both of them they consider as H bridge, but each one of them is half H bridge, or only two MOSFETs, as we will see later in the data sheets. Okay, so from here I can say this board consists of two sections. Okay, this is the high power section, okay, and this one is the low power. So you can see here that's why you can see even the connector here is kind of more bigger and heavier than the connector here. Okay, so this one will be connected to, later again we will see the wiring, so this one will connect it to the DC power source, DC, and this one connected to the motor. Okay, so this all will be high power side. Okay, and the other side, or the lower side, will be the low power, where will be connected to the Arduino. In this case we will use the Uno to control the module. So yeah, so as we said, these are the two main ICs, and this guy here is just I believe it's buffer of what they call line driver, line protector. Okay, so this is just a buffer to protect the control lines from the Arduino to the main IC switch, the BTC. And here we can see on the silk screen that all the information of these 8 pins is printed down here, so we can know how to connect them to Arduino. So here we have the VCC ground, right and left, because we have two chips set, so that's why we have right and left at the bottom. So the right one will have the right IS, which is used to measure the current, right enable, and the right PWM to control them, the right side. And also we have the left side, which is the left IS, which is the left current measurements, left enable, and left PWM.
Okay, so here is the module, guys. So as we can see here, this is what we talk about with your two half bridges. Okay, this is the output connectors to the motors or to the load, and also to the power source that will sync to the load or supply to the load. Here is the buffer, or the what they call the line driver, I guess. Anyway, and here we can see the big fat heatsink. So actually I got some comments on the design overall before we proceed with the wiring. So let's disassemble the heatsink, then we see what's beneath it. We see if got any thermal paste being applied, or any seal pad or anything else being included, which is nothing. It's clear. And if you see guys, it's kinda, yeah, it's exactly what I expected. It's really dangerous design like this, you know. If you see here, these pads, these are exposed pads actually. These two pads are the output of the load. Okay, so these two pads, if you see, got a lot of vias on this pad where they connected to the output of the load. So one to connect the high output and the other one connect to the low output. So it's mean that's a positive and negative, I can say. And they are directly connected to the heatsink. Which is really not good idea. They're actually connected without any insulation or protection added. So if we try to buzz it, I'll use my multimeter. Okay, so here's my lead. If you hear it in the background, you can hear the beeping. So the output is here. So if here we go. Is a dead short for sure. Is the output unexpected, and the other one is here. Can you hear these guys? Is direct short. Wow. So the only thing that's prevent these two of shorting to each other is the coating of the heatsink. Okay, if any small scratch on these 2 points, it will be dead short between these two, and there will be a lot of smoke come out of this module when you power up. So I don't know how they think like this and why they choose to put the this heatsink in this place without adding any insulation. Plus I can see this one is not really smooth. It's got like some extra solder paste being penetrated through from the top layer, I can say. So it's not fully flush, and if you can see here, get even something being pressed, you see, but like press on the heatsink. So if it just move a bit, then happen to be scratched, then it will be dead short and will be a lot of issue happen to the output when we supply the power. So yeah, this is very bad. So be careful guys when you're using this module to either take out the heatsink or you apply some insulation cover, then you put back the heatsink again. But I guess for me, since I'm applying very small load at the output, so I will choose not to install the heatsink. I'll just use it as it is.
Okay, so before we go and have a look at the data sheet, let's have a look at the schematics of the module. So you can see from here, let me select the red. Are we red? Yeah, here. Okay, so you can see here, this is what we talk about. These are the main two ICs, one here, one here. This is the one for the high side, one for the low side, or what they call it on the module, left and right side. Okay, so these are the two power connectors, the one we talk about. Where we can see here, this is the input connector, where we go to the VS of these two modules, and this one go to the ground. Okay, this is the main input connector, and this is the output one. So if you notice here, we got two outputs from individual ICs, which is the high side and low side. Okay, so one IC, let's say if this one will be activated to output the VS or the high, okay, to the load. Okay, this is the load, let's say is a motor. So this one we should connect it to the ground. Okay, and vice versa, if this one is being activated, later we'll see in the coding, if it's activated to output a ground, so this one we can activate it to set to VS. So we can say that at the first scenario where we activate the positive at the first side and the negative at the second side, so we can be here positive and this one will be negative. So the direction might be on this side, and on the second scenario, when we activate the positive here, the negative will be here, so the direction might be on the other side. So with this, we have controlled the direction of our load. On the other side, there's another function we might control, another parameter of the load, which is the amount of the power that can pass to the load. Okay, so we have this pin, okay, which is the input. We're controlling this pin in on each side of the H bridge by sending PWM signal here. We can control the amount of power flowing to the load. Same goes to the other side. By sending PWM signal on this line, we can control the amount flow to the load on the other direction as well. This is what that's related to the I can say the high power of the circuit, which is, yep, this guy here, or this side will be high power, and the other side will be the low power. So the low power, again, is just a buffer, okay, or the line driver. And yeah, so you can see here all these control signals being passed to the pin header or the connectors, where it will be connected to the Arduino later to control the high power circuits. Okay, so regarding the data sheet of the BTS7960, again, as we said, it's a high current PN half bridge, so that's why we need two pieces of this guy to make a full H bridge, and it's able to handle 43 amp, and it's from Infineon. Okay, let's see what else is important to us. Okay, so this is the internal construction. As we can see, is only two MOSFETs, one to control the high side and another one to control the low side to the output, and we have a logic controller, which is the gate drivers and also the interface with the MCU. Okay, so here are the pin out of the device. So you can see here, pin number 1 is the ground, pin number 2 is the input, where we can control the high or low side, and the pin number 3 is the inhibit, where we can set or can put the device into a sleep mode. Number 4, number 8, they are the output of the bridge, or the half of the bridge, and number 5 is the slew rate pin, where we can control the slew rate of the output, and also we can drive this with a single resistor between the pin and the ground. IS is the current sense and the diagnosis. So this pin is used to output a voltage that is proportional to the load current, and also it will output the Imax or the Vmax if got any issue, as we can see later. Okay, but this one, actually, I'm not really encourage you guys to use this pin to measure the current of the load. Why? Because especially if we are driving the module using the PWM signal, so the output of this pin will be pulses, so it won't be stable and won't be accurate. So I suggest to use an external current sensor rather than using this pin. Okay, because if we are using PWM signal, so the signal here, let me go up. So the signal, let's say we are driving the high side. We are driving this with the PWM signal, so this one will be on, off, on, off, on, off. So the output of the IS will be pulses, like zero, maximum load, which is very inconsistent and not that accurate, and required a lot of work to filter out the value or the final value of the current. So I suggest, I don't recommend to use this pin overall. And pin number 7 is the supply pin. Okay, so you can see here the supply voltage, it can go up to 45 volt DC for sure, and the logic can go up to 5.3. This means it's safe to be used with a 3.3 volt and 5 volt digital logic. High side, low side continuous can support up to 40 amp, but if only a short pulses can go up to 60 amps. What else? Yeah, so here we can see, this is the one I'm talking about, the IS pin voltage can go up to 45 volts. Okay, what else? So you can see here there's a lot of protection. There's over voltage, under voltage shutdown, temperature protection, current limitation. I've got a lot of protections, even like short circuits protections, etc., yada yada yada. So yeah, here what we are talking about just now about the IS. So again, the IS is the voltage output that proportional to the load current. So if a normal operation, so the voltage here will be coming from the I load, which is the current that's been supplied to the load. However, if got any fault issue with the module, so the output here will be the I limit or I max, which is the highest output pin somewhat here. So it's very, we need to be very careful when we deal with this pin. Okay, what else? Okay, so here is the an example or typical circuit, I can say, of BTS when used as a full H bridge, which is, I can say, it's kind of match the schematics of the module that we are using in today's tutorial. So you can see here they're using again two BTS, two half bridges to construct one full bridge. This is our load, which is our motor, okay? And here are our control signal that are going to the MCU. Okay, so before we start with the firmware for our module, let's talk about the wiring. Okay, so let's take this guy here. Yep. Okay, let's take that. Yep. Okay. So here is the connection or the wiring of the module to the rest of the components. So here, the first two pins, okay, from the top of, we start from the capacitor here. These two pins, it must go to the DC power supply, or battery also can, okay, either one, no problem. Make sure you connect to the correct polarity, okay? The first one must be negative, the second one is positive, okay? So this is the source or the power supply, okay? The second two are the positive and negative to the load, or here we are supplying, or our load is the DC motor. Okay, done. So now we have finished again, we have finished with the high power, we come to the low power circuit. Okay, so the low power circuit, again, we have Arduino. So we can see here we have the 8-pin headers. So the first pin here will go to the ground, okay? The VCC go to the right and the left enable and go to the 5 volts. Then we have the left and right PWM go to pin number 5, pin number 6. So here is the low power or the logic signal connection. We have the VCC, right enable, left enable, both of them go to the 5 volts, okay? The ground go to the ground, and the right PWM go to pin number 5, left PWM go to pin number 6. Okay, so you just follow this wiring, then should good to go. And actually the right and the left PWM, you can choose any one, not I mean, it's not a must to use these two pins, but otherwise you need to follow, and the firmware later you need to change it accordingly. Well, so now regarding the coding, first let's start with defining the PWM signals, which we have the R PWM, okay, and also the left PWM. So the right, I believe we connected to pin number 5. And define left PWM, which is 6. Okay, good. And also let's have a boolean thing. This one, let's have it for direction. Equal to 1. So now in the setup, where we will put the code where it will be run once. So we have the beam mode. Here will be RPM. Sorry, RPM. The right pin, and here we have the left pin. Let's put comma. So this one will be the left. Okay. So this one will be output. Should be capital output. Yep. And the other one is output as well. Yep, should be fine. Now, after we initiate them, we declare them up there and we initiate them. So now we come to turn them off, so they won't do any funny things while it's in the setup function. So we have analog right. Yep, analog right. So here we have the R PWM, set 0 to turn them off, and we will do the same for the left one. Okay, let's check. For sure we don't do much, we didn't do any mistakes, so now, yep, compiler should be hit. So now we check the direction. If the direction more than, or if the direction is 1, okay, so what we will do, if it's 1, So we have analog. Let's copy this one. No need to keep reading. Else do this. So here we go. Here we go. So okay. So if the direction is 1, let's say it's clockwise, for example, so the right will be 0 and the left will be, for example, 25, just for testing. Else, if it's 0, so the left should be, this is left, should be 0, and the right, maybe we put it like 100. Yep. That's it. That's it, guys. So this is how we control it. There we go. So how we control it is we have the direction. After we know the direction, whether it's clockwise, counterclockwise, then we need to control the right and left PWM signals. So if you send to the, say, we send the data or we send the PWM to the left side, let's say it will rotate clockwise. If we send to the right, then it will go to counterclockwise. As simple and easy as this. Okay, so now I will connect it to my Arduino and burn the code, and we see how the motor will behave.
So here it is, guys. So here is our module, and as you can see, I took out the heatsink. I don't trust the heatsink anyway. So it's been linked to the Arduino, and this is the battery pack, and this is connected to our load, which is the DC motor, exactly following the schematics I showed you previously. So here, as you can see, the motor is slowly rotating clockwise because we set the direction. As you can see here, the direction is set to 1, so the motor is running at 25. So now if we change the direction to 0, sorry, and we upload again, so now we should see the rotation of the motor is changed to the other direction and faster. Here we go. You can see here the motor is rotating the other direction, which is counterclockwise and faster because we send. Then we'll go to the else branch where we'll send the signal to the right PWM and the value will be 100. Okay, so with here we can change the value of the PWM, let's say 250. Then we can control the speed by manipulating the R PWM signals. You can see I changed to 250. There we go. You see the speed now is being adjusted or increased. Then I can decrease it, let's say to 50. There we go. So now I wanted 125 but counterclockwise, so I just send 1 here and here 125. There we go. So you can see here, guys, the direction is being changed and also the speed of the motor being changed as well. Okay, so as you can see here, I'm using the oscilloscope now to show you why it's not a good idea to use the motor driver or the BTS, this module, to measure the current of the load, which is the motor in this case. So I'm using oscilloscope now connected to the IS pin, okay, of the, I believe it's the right channel ISP. I believe it's the right channel of the BTS. This is the IS pin, okay, and this connected to the ground. Here we go, guys. So now I guess I'm sending 25% to the PWM signal, and you see the output of that pin, of the IS pin, is just give you a pulses because we're using PWM, so the output is not continuous. So like whenever the PWM is high, will give you signal, if no, will bounce down to the negative side. So this is the output. It's not pure DC that can give you exactly the value of the current that's been drawn. So now I will change I have changed the speed of the motor now, which is increased the PWM signal. So now you should hear the motor is rotating fast in the background, and you see exactly the same whatever you increase or decrease, but you can see the pulses getting like more frequent. Okay, so with these guys, that's why I don't really suggest to use this module for the current measurements. Actually, it could be used, but you need to filter out and rectify all these signals, which is not an easy job to do. So it's better just to use an external module instead of this unit. So with that, we have come to the end of this tutorial. I hope you have learned something. Let me know if you need any further clarifications or any questions. Do let me know down in the comments. See you soon.